All right, guys, to finish up chapter 2, let's talk about polyatomic ions. So we talked about monatomic ions. We talked about how you can look at the periodic table and tell what a charge should be on an ion. But some ions are molecules. They actually combine with one another and they still hold a charge. Now, there is a list in the slides, and there's a list in your book on page 72, table 2.5. that gives you some polyatomic ions. Well, it's important to understand what they mean and how to figure them out. Now, as for their charges, that's something for right now you just have to memorize, okay? But I'm going to write a couple down here. SO4, 2 minus. Okay, NO3 minus. All right. What else do they have up here? ClO3, I think. Yeah, let's use ClO3. Sure. Yeah, ClO3 minus. Okay. If they have oxygen, okay, and it's usually the second atom in the molecule, the way we name these is you take the root of whatever's bonded to the oxygen, and for these, you add ATE. So this is sulfate, and this is nitrate. And this is then chlorate. So the ATE, when you see it in a name, means something bonded to oxygen. So if it was, hamburger ate, it meant that a hamburger is bonded to oxygen. And again, that sounds ridiculous, but you get my point. Now, if I remove an oxygen, but keep the same charge. Remove an oxygen, same charge, NO2 minus then, and over here ClO2 minus. Okay. The name changes slightly. One less oxygen, same charge, then the ate becomes ite. So this is sulfite, nitrite, and chlorite. Okay. So same charge, one less oxygen. So if you know the eights, you automatically know the ites by following that simple rule. Now, there are some on that list you'll see that don't follow this rule. I just want to see which ones they give you that don't. Yeah, they give you cyanide. That doesn't have any oxygen in it, so it's not going to have an 8 or anything, so that's cyanide. And they also give you OH minus, which is known as hydroxide. Okay. But the rest really follow this rule. Okay. So PO4 3 minus is phosphate. Okay, so that means PO3 2 minus, if it exists, would be phosphite. Okay, and we come over here to our friend chlorate and chlorite. This is actually an interesting one due to the way chlorine can bond. There's actually another form, ClO minus. Okay, and what color didn't I use? I used blue, I used red. How about green? And there's one up here, ClO4 minus. Okay. If I'm one less than the ite, and this is the best example, there is other examples, this is the one you see the most. If there is less than the ite, we put the word hypo in front of it. So this is hypochlorite. And if I'm one more than the 8, I know you'd want to say, okay, then it's hyper. For whatever reason, they got rid of the high and just made it perchlorate. Now, you should familiarize yourself with those polyatomics on the table in 2.5. I do want to point out an organic one known as acetate, and its name comes from the organic term. That's C2H3O2 with a minus charge is known as acetate. And that's the inorganic way of writing it. There's also the organic way of writing it, and you might see it written this way, CH3COO minus. That's also acetate, just to point out, 2 carbons, 3 hydrogens, 2 oxygens. It's the same compound, but written out as kind of like the way it bonds. Okay? So, 8s, memorize those. Take an oxygen away, I become ites, keep the same charge. Take another oxygen away, I become hypoite. Add an oxygen to the 8, I come per-8, whatever it is. So permanganate is MnO4. Do they have that one on your list? Yes, they do. MnO4 minus. So if manganate existed, it'd be MnO3 minus, and so on. Okay. Now, we can also, to the ones that have multiple charges of 2 or more, okay? There's also, while I'm talking about it, let me just write this down. There's also 2 other polyatomics that have charges that are positive. This is ammonia with an extra proton. It's known as ammonium. Ammonium. And this is known as hydronium. It's a water. And we'll see these more when we do acids and bases. Okay, so hydronium and that. Now, if we go to the ones that have multiple charges, okay, so PO4, I'm going to pick ones that I didn't use yet. PO4 3 minus, and let's use carbonate, which is CO3 2 minus. So this is known as phosphate. There we go again, phosp. And then the ATE ending, this one is carbonate. For you Star Wars fans, if carbonite really existed and we follow those rules, one less oxygen, same charge, that would be carbonite, right? All right, for you Star Wars nerds. There's a thing we can do with these. And what we can do is actually add a hydrogen to them. Now, adding a hydrogen's a plus, and we're going to add it to a PO4 3 minus, which if we do that, we're going to get out HPO4 2 minus. Very creative here. Since this is phosphate and this is hydrogen, we call this ion hydrogen phosphate. This is carbonate. We're going to take an H plus with a CO3 2 minus. Put them together, a plus and a 2 minus leaves me a minus 1. HCO3 minus is hydrogen carbonate. And you might see it written as the generic term of bicarbonate or bicarbonate. Okay. Now, since this has a 2 minus charge, guess what it can do? It could take on another hydrogen, actually. And if we add another hydrogen to it, okay, we're going to get out H2PO4 minus 1, because for every hydrogen we add, we take away a negative charge. This one is known as dihydrogen phosphate. So how do we utilize these? Well, you utilize them the same way you utilize any of your ions. Okay. So if I were to name a compound, right? Let's go through this again. A little quick review on naming compounds. If I were to name a compound and say, okay, I have, Fe3 S. It's going to be Fe2S3. Let's do that. Okay. If I were naming this, what we learned is, okay, this is a minus. I'll do it in a different color so we can see it. This is a minus 2 charge. Minus 2 times 3 is minus 6. Minus 6 divided by the 2 gives me a minus 3. Turn it into a positive, and that's a plus 3. So this would be iron 3 sulfide. IDE because it's its elemental form. Now, I'm going to write out the same thing, except I'm going to change it, and I'm going to make it SO4. Now, with SO4, you can't do this. I need 3 of them, and I'll show you via the crisscross. Okay? If I want to make this compound, iron 3 sulfate, I see that ATE, I know I'm a polyatomic. I know iron 3 has to be Fe3+. I know sulfate because I know my polyatomics from that table, SO4 2-. Okay. We do our crisscross. A 3 would come down here, a 2 would go there. So this would be Fe2, SO4, and I need 3 of them. Well, you can't do that because that means there's 30 or 43 oxygens. That's not going to work. So we need to use parentheses and put the subscript outside. That means I have 3 sulfates, essentially 3 sulfurs and 12 oxygens bonded to the 2 irons. Okay. So let's try another one. Let's do lead 2 phosphate. Okay. So lead is Pb, and the Roman numeral tells me the charge. Lead 2. Phosphate from my table is PO4 3-. We do the crisscross method, bring these charges down as the subscripts, Pb3, PO4 2, and we've made lead 2 phosphate. Okay, so let's look at this one. How would we name CaNO3 2? Okay, so Ca is calcium, and since it's in group 2, we don't need a Roman numeral. Okay, and this is nitrate, so this is calcium nitrate. All right, now I'll give you homework, and there is a whole bunch of problems up on Blackboard. All right, I think there's like 40 or 50 of them, both going from name to formula and formula to name. But there is one more part I want to point out. You may see a compound that looks like the following. MgSO4 times 7H2O, which is Epsom salt. Or something like this. Copper 2 nitrate pentahydrate. Now, okay, there's your 2. Name this, worry about this next. Name this, worry about this next. This is magnesium sulfate. I'm just doing this for board space. You'd write it out that way. As soon as I see times waters, I know it's a hydrate. The word hydrate means times waters. Okay, so as soon as you see times waters, write the word hydrate. Now, I need to say how many hydrates there are. Okay. Here are the numbers. Okay, 1, and there's a table in the book. Page 73, table 2.6. Table 2.6 on page 73. 1 is mono. 2 is di. 3 is tri. 4 is tetra, like Tetris. If you ever played Tetris, each shape has 4 pieces to it. 5 is penta. 6 is hexa. 7 is hepta, not septa. Septa is transportation down in Philadelphia. 8 is octa. 9 is nona. 10 is deca. So to name this properly, magnesium sulfate 7 hepta. So we'd go hepta hydrate. So let's look at this one. Pentahydrate. Now, if I'm working from name to formula, I always start here. If I'm working formula to name, I always start here. But pentahydrate, I know that's going to be times waters. Penta, like the pentagon, 5-sided, 5. Copper, 2 is Cu, and since it's copper 2 is 2 plus. Nitrate from our list is NO3 minus. Do the old crisscross. I'm left with Cu parentheses NO3 2. I'll make a little bit better 2 for you. There you go. Okay. So that's how you name compounds with polyatomics and hydrated compounds. So I'm going to assign you some homework, and we can go over this in class when I'm live again on Monday, and we'll start chapter 3. But this is the last information for the exam. That being said, let me assign the homework first. Okay, our exam is going to be a week from today, which is Thursday, the 11th. So let me put the homework up first. Page 90. And let's see, naming compounds. Here we go. Last one I gave, I think, is 2.89. So we're going to go 2.90 to 2.93. We're skipping acid naming. We'll do that when we do acids and bases. .97 Don't worry about figuring out their mass. Okay, if it asks for mass. I'm just worried about naming. We're going to do massing in chapter 3. 2.97 okay, and then 2.10 and 102 and 103. Okay, so 2.97, 2.100, 101 and 102. No. That's it. 2.97 will do it. And how about 2.102 should work out. Yeah. 2.102. Okay. All right. So that's the homework. Draw a line there. Exam. Unless you guys want it different, because I'm going to have to start new stuff in between anyway. Exam 1, 6, say the 11th, yeah, so 6/18/20, which is a Thursday, and you can take it all day on Blackboard. Now we can review on Monday, or Monday and Wednesday, no big deal. But I do have to start chapter 3, which is up online. And what should you cover? Chapter 1 and 2. All right, you should be able to do the homework in chapter 1 and 2 that's been assigned. I would focus on conversions. sig figs, density, isotopes. And by isotopes, I mean finding that percent abundance, protons, electrons, and neutrons, that kind of stuff. That was covered in 1 and 2. What else am I thinking about? Scientific notation. We talked about naming compounds. And by naming, that should be not naming. I know we're from NEPA, but come on now. Naming compounds. Okay. So conversion, sig figs, density, isotopes, scientific notation, naming compounds. I can't think of anything else that we did. I mean, temperature, but that's more conversions and stuff like that too. But if you could do all the homework that was assigned in those chapters, there's nothing I could throw at you that's going to be more difficult. Now, that being said, lectures are going to be more like this, where we're not live all the time with me doing lecture. I did it for the first couple of weeks to get your feet wet and understand what a virtual class is, but there's just not enough class time set up for me to just do lectures on there. I mean, we're 2 weeks in, I covered 2 chapters. I'm going to expect, and I'm going to be uploading videos of chapters, chapter 3, chapter 4, and expect you to watch them on your time and come to the live lectures with questions. That doesn't mean I'm leaving you stranded. That doesn't mean I won't go over the homework. That doesn't mean I won't help you. But the thing is, you have to learn. I'm still going to be lecturing, but you're going to have to take the time on your end to watch the lectures and take your notes and come to the live sessions with questions, because we don't have enough time to cover the 8 or 9 chapters we need to in order to move on to Chem 2. Okay, so this will be the first one. I suggest with just subscribing to the channel, also hit the bell on the channel so that you know I'm going to be when a new video is uploaded and you get a notification. Okay. So work on this homework over the weekend. You may see a chapter 3 video over the weekend coming at you. Okay, leading us into Monday. But chapter 3 won't be on exam 1. I will go over any homework you want to. So I suggest in the next 4 days you go over all your homework in chapter 1 and chapter 2 and come with questions on Monday. If you do not come with any questions on Monday, I'm just going to assume we know everything and we're going to move on. All right, guys. Have a great weekend. Thanks a lot.